My name is Sergi Almar, and we'll be covering a little bit about the Spring WebSockets. I know that it's not the best time right after lunch, right? So hopefully you're not going to get asleep, and we're going to make that fun. Okay, great. So the agenda of today is basically a quick introduction to WebSockets. I know that most of you know about WebSockets already, so we're going to keep that short. And we're going to focus on the support in Spring. Right? So we're going to see a little bit about the flow, and we're going to see about the components involved in this flow or the processing of these messages, because it's really important to understand, right, all the components involved in the processing. So after that, we're going to see the new features in Spring 4.1. Actually, the WebSocket support has been around since Spring 4, but in Spring 4.1 we have new features like the WebSocket scope. We have also a sock.js Java client, which is quite useful if you want to have or to do like server-to-server communication, and also for the load testing to your Spring applications. And we're going to talk a little bit about the performance and monitoring, which is basically, well, we've added some stuff right on this part as well. Apart from the new features in Spring 4.1, there are a couple of projects that support also to WebSockets. So one is the Spring Session. It's a new project. It's not final yet, but it's basically a way to synchronize the HTTP session to the WebSocket session. We're going to see that as well. We're going to see a little bit about Spring Security, the new release, which is about to come out, which has some WebSocket security support as well, which is quite interesting because there's no specification or there's nothing in security in the JSR, right? So Spring Security is basically trying to add this security on top of our WebSocket messages. And the last thing that we're going to see is a little bit about testing, the different ways to test our WebSocket applications. So I guess that you're here to learn more about real-time web. So I would say that every single developer should know about real-time web. We've been trying to do real-time applications for a long time when we didn't have WebSockets with long polling, streaming, and so on. But HTML5 introduced the WebSocket concept, so we have like right bidirectional communication from the server side to the client side and the other way around. But that's just the beginning, because HTTP2, for instance, also defines this bidirectional flow of messages between the client side and the server side. So that's just the beginning. We're changing the way that we communicate with clients and servers. We have now the bidirectional communication. So what's the life cycle of a WebSocket? We're going to start with an HTTP request. And this HTTP request is going to be the handshake. We're going to ask the server whether we can upgrade to the WebSocket protocol. So we're going to use the HTTP protocol to switch to the WebSocket protocol. So if the server is happy with that, it can accept the WebSocket connection, then we're going to switch to WebSocket protocol. So at this point, we're going to leave HTTP. So that's the only relationship between HTTP and WebSockets, right? At this point where we do the handshake. After that, we're going to move to the WebSocket protocol, which is like going directly to TCP. So we're going to have this bidirectional communication. We're going to send frames from the server side to the client side, and the other way around, right? So the client side will send frames also to the server side. And of course, there's going to be an end, so the connection can be closed by either the server side or also the client side. So that's going to be kind of the life cycle of the WebSocket connection, right? So that's part of HTML5. That means that it also defines, right, how to establish this connection using JavaScript as part of the specification. So here's the handshake. So as said, we're going to use HTTP only for the first handshake, where we're going to negotiate some stuff, like whether we are using a protocol, whether we can use the WebSocket protocol as well. Because whenever you have a WebSocket, that's going to be like a raw socket on the web layer. It's like if you just start a TCP socket, but in the web layer. That means that we won't have any protocol like what we have in HTTP. In HTTP, we have a protocol that defines the semantics of the request. But now, in WebSockets, we won't have anything. So that's going to be like a blank page where we're going to send and receive messages. So in this handshake, we can negotiate also a sub-protocol to be used during this frames exchange, right? So we'll be able to negotiate this sub-protocol And basically the server side will agree on that sub-protocol as well. So the server side will basically return a 101 response if everything went okay, right? So other responses which are not 101, that means that the negotiation failed, right? And maybe we need to fall back to some other way to have this bidirectional communication. So that's just, well, how we start the WebSocket connection. So this presentation is focusing on Spring WebSockets, on how Spring adds support on the WebSocket layer. So we have a GSR, which is the basically the Java API for WebSockets, which is the GSR 356. So why should we use Spring WebSockets instead of the plain GSR? So Spring WebSockets adds several stuff on top of the GSR. Of course, it's built on top of the GSR, but it provides support for SockJS. SockJS provides you some fallback options. So that means that if your client side, for instance, if you're using Internet Explorer 8, 9, you won't have WebSocket support. So if you're using a client which doesn't support WebSocket, then SockJS will make sure that your application will still run, but it's going to use any of the fallback options like pulling or streaming. But at least your application can be used, right, with this kind of clients. It has also support for the STOMP subprotocol. So we have said that whenever you have a WebSocket, you don't have any kind of protocol. So that's just sending raw data and receiving raw data. So the negotiation of a protocol is really important. So STOMP is basically what's supported in Spring by now. So maybe other subprotocols will be added. But by now we have support for STOMP as the subprotocol. And also security, right? So security is really important even, well, in every single web application. But if you have this WebSocket connection, you're not in HTTP. That means that securing HTTP requests won't affect the WebSocket frames. So the GSR doesn't define anything regarding security, but we can see that Spring Security can add this layer on top of our WebSocket. And of course, integration with the messaging components, but because Spring 4 introduced this messaging module, which basically takes some components from Spring integration and makes them available in the core. So Spring integration is using this messaging module now, as long as the core as well. So we have like integration with these messaging components and also the Spring programming style. So these are some reasons why you should go for Spring WebSockets instead of the plain GSR. We're going to focus on STOMP over WebSockets. Actually, Rosen did a really nice presentation last year here in this conference, which covered the WebSocket API and actually the initial version of the WebSocket support. So if you want to learn a little bit more about the WebSocket protocol and API, just see the presentation, which is on YouTube as well. But we're going to focus on STOMP over WebSocket because it's basically what you'll be using, right, if you have a kind of real world application, because you want to have semantics. So we're going to turn our communication into kind of a message-driven communication, right? So it's basically dealing with messages instead of HTTP requests and responses. So as I said, we're going to have support for the STOMP subprotocol. So STOMP subprotocol is a really simple messaging protocol, which is kind of similar to what we have in HTTP, because if you take a look at how a frame or a message in STOMP is defined, you're gonna see similarities between HTTP and STOMP. We have a command. So this command basically defines the semantics of the message, what needs to be done. We have actually commands for the client side and for the server side. So as we are dealing with a kind of message-driven architectures, we'll basically send messages to destinations and receive messages from those destinations. So we have commands like send, subscribe, and subscribe. We have AX and NAX, that's on the client. And on the server side, we have messages. So basically the server side will send the message to a destination. We have the received command, the ever command, right? So depending on where we are, we're going to receive some commands or some other ones. So we're going to use STOMP over our WebSocket connection. So we're going to establish the WebSocket connection, and what we're going to send is always a STOMP message. And the other way around as well, we're going to receive STOMP messages. So these guys are going to be called frames. We're going to send and receive frames. So let's understand how these frames are processed, how Spring helps us out in processing these kind of WebSocket messages. So this is the workflow, which is simplified, right? So it's kind of having the main components. We're going to receive a WebSocket frame. So this WebSocket frame will be basically a STOMP message, right? So STOMP message, which will be processed by or sent to an endpoint. So this endpoint is basically built on top of the GSR, right? So it's implementing the main GSR components, and it's going to take care of this message. But it's not going to be processed by the endpoint. The endpoint is just receiving the message, and it's delegating this message to some handlers. But this message is not going to be delivered to the handlers themselves. It's going to be delivered to a channel called the client inbound channel. So every single message that is sent from the client will be sent through this channel. And this channel will have several subscriptions, right, or several subscribers, which are the message handlers. These message handlers are the real guys, or the real processors of the messages. So whenever we are using a STOMP over WebSocket, the important thing to understand, to know, is that we need an extra component, which is a broker that understands about the protocol itself, right? Because this broker will understand what a subscription is, will understand what a message is, will understand what an error is. So everything will be actually processed and understood by the broker. So we're going to see that in these handlers, we're going to have some of them which are message brokers, which will understand actually the STOMP messages. So these handlers at the same time will send some responses to the clients, and these handlers will send the response to this client outbound channel. So every single message which is sent to the client will go through this channel, and that's just a normal messaging channel. So that's part of the core, as in of this new module for messaging, which is actually also used by a Spring integration. So it's going to be sent to the channel, and then it's going to be streamed or sent back to the WebSocket session. So the first part of the workflow is the endpoint. As said, it's kind of a bridge between the GSR 356 to these guys called the WebSocket handlers, right? So it's actually the bridge between the standard API and the Spring guys. So the responsibility of the endpoint is basically getting the message, decoding the message, and find the right subprotocol handler, right? So actually the subprotocol handler is the one that will decode the message. So by default, we're going to have STOMP as the subprotocol. Even if you don't negotiate that in the Handshake, we're going to use STOMP, right, as the subprotocol. So this message will be sent to, as said, the client inbound channel. So we're kind of decoupling, right, this message from the handler or the one that is processing this message. So the endpoint is also responsible to send application or to publish application events. So for every single message coming in, not for every single message, but for some of the messages that come in, we're going to have some application events. For instance, for connections, for disconnections, for subscriptions, for unsubscriptions. So we're going to have an event every time a client connects, or every time that we start a WebSocket session, every time that the client disconnects. And the same applies to subscriptions. Every time that a client subscribes to a topic or to a destination, we're going to have an application event, which is quite interesting or quite useful, for instance, to track the user presence. Right? We're going to see that later on. So these are the applications events that we're going to receive. Actually, they represent the STOMP messages. Right? So in STOMP, we have a command called connect, which happens when we request a connection to, in that case, the broker. We have the connected event, which happens when we are successfully connected. And we have the disconnect event, or actually command, which happens when we disconnect, right, from the WebSocket session. We also have the subscribe and unsubscribe commands. So basically, when you subscribe to a destination, we're going to have this event sent or published, where you can implement your own listener to get this event. So here's just an example on how to implement your own application listener. We are creating a listener for the session connected event. So that will happen when the client is successfully connected. So this event will give you the session ID and many other attributes which are useful to identify this new session. So how do we configure the endpoint? So the configuration is quite straightforward. So we're going to be using Java config in the slides, but you also have the XML support for the configuration. So we're extending this base class, the WebSocket message broker configuration support, and we're registering an endpoint. Right? So we're defining the path of this endpoint. So that means that every time that a client connects to this path, we're going to start a WebSocket session, and all the messages are going to be processed by the endpoint that we have seen. Additionally, you can define that you want SockJS support. So notice how having these fallback options is quite straightforward in the configuration. So it's just a matter of adding this with SockJS support. So now we're going to have fallback options to make sure that our application will work even if the client doesn't support WebSockets. That means that if you don't support WebSockets, we're going to fall back to polling or streaming. So defining the endpoint is quite straightforward. All right, so I have a demo which is a chat application, and we're going to work with this chat application throughout the presentation. As we are building real-time applications, it's actually really nice to have, or it would be really nice to have real-time feedback as well, right? So if you like what you see, you can clap and tweet. If you don't like what you see, you can throw tomatoes and tweet as well, right? So that's the deal. Deal? Yeah? Game on. Okay. So here's my chat application, right? So we have a really simple login page where I can define my username, right? So I'm going to enter the chat. I'm going to add a new user here. So I'm going to type the same URL, and I say I want to log in as John, for instance. So here we see that both windows have the same participants. So whenever I logged in with the second browser, I've seen that John has actually joined the room. So here there are several things happening, right? So the first thing is that we have subscribed to a destination. And the second thing is that, well, we have actually sent messages, right, whenever a user has joined the room. So let's see how this works internally. So I said the endpoint is the one that's going to process every single STOMP message coming into the application. So this endpoint will be responsible to send application events as we have seen. So I have here this presence events listener, which is basically implementing this application listener interface. And on application event, I'm basically processing the session connect event and the session disconnect event. So basically, these events are going to be thrown every time that we start a WebSocket session and every time that we kill a WebSocket session. So whenever I logged in as John, this event has been triggered. So in the processing of this event, what I'm doing is I'm sending or broadcasting, right, this joining, right, to all the connected users. And the same happens when I'm disconnected, because let's say I want to close this window here, and boom, in the first browser, I see that this John has disconnected. So that's because I received the disconnect event, and I basically broadcast this disconnect event to all the connected users. Sorry. So that's a really quick demo. So you have this application on GitHub, so you can take a look. So it's going to have all the features that we're going to see throughout the presentation. So that was a really quick demo on application events. Right? So basically sending or processing these connect and disconnect events. So let's continue with the workflow. So after we go through the endpoint, we're going to send these messages to the client inbound channel. So this client inbound channel will delegate to all the subscribers. And we have different subscribers. Usually, we're going to have 3 subscribers to this client inbound channel. And these different 3 subscribers are going to process the messages based on the kind of destination that we are sending the message to. So we're going to have destinations which are application destinations. We're going to have destinations which are broker destinations. And we're going to have destinations which are user destinations. So the application destinations are processed by the first handler. So these application destinations let you intercept the message so you can implement some logic and actually treat the message itself. But as said, the broker is the only responsible, actually is responsible to understand what needs to be done with the STOMP message. So we're going to be able to add some logic before delegating to the broker. So the second handler that we're going to have is actually a broker that understands about STOMP. Right? Actually, we have 2 choices here. Either we go for the built-in broker, because Spring WebSockets has a built-in broker. So that means that you don't need a full-blown STOMP broker to get started with the Spring WebSockets. That's quite useful for development and also for testing. But at the end of the day, if you want to scale this application, you will delegate or you'll rely with a full-blown STOMP broker, like RabbitMQ, for instance. So that's why we have the second handler. This STOMP broker relay message handler lets you delegate the STOMP messages directly to a broker instead of dealing with a message in an embedded broker. So that's basically what you want to do if you want to scale a WebSocket application. And the last type of destinations that we're going to process is the user destinations, because sometimes we want to send a message to a specific user. So we're going to see that every single user will have its own destinations. So we can send messages to those specific destinations to send a message to a particular user. So let's talk a little bit about the destinations and how we define application destinations and broker destinations. So that's going to be done in the same configuration that we have seen. Right? So we have seen the WebSocket message broker configuration support. So now we're going to define or configure these destinations. So the first thing that we see here is that we enable the simple broker. So we have said that we have 2 options here. So at the end of the day, we need a broker to process the STOMP messages. So we have the option to define the embedded simple broker or the broker relay, which we're going to see later on. So this configuration basically means that everything that is sent to /q/whatever or /topic/whatever is going to be sent directly to the broker. In that case, we are defining the simple broker, so we're going to use the embedded broker, right? And the second line here is setting or defining the application destination. So that means that every time that you send a message directly to /app/whatever, this message is going to be forwarded to your controllers. We're going to see that the application destination, well, the handler will basically forward to your controllers, which are just normal, like MVC controllers, having some special methods to handle the messages. So set this simple notation method message handler, which is the first one that we saw in the list, is the responsible to get these kind of messages sent to the application destinations and is going to forward these messages to your controllers. These controllers are basically what you implement in Spring MVC. So we know that we implement request handler methods inside controllers with the add controller annotation or with the add rest controller annotation. So now we're going to have controllers with request handling methods and also message handling methods. So these message handling methods are quite similar to the request handling methods in Spring MVC. They have really flexible signatures, and you can plug in or pass anything as an argument. You can pass the message, you can pass a POSIO annotated with add payload. You can actually get the principal, get variables from the destinations as well. So these methods are really, really flexible. So let's see an example of an application destination. So in our components, in our controllers, we can actually intercept subscriptions and messages. So here's the example of handling a subscription. So notice that the client will subscribe to /app/chat.participants. So that's actually an application destination because we have defined this prefix to be an application prefix. So we're sending this STOMP message, right? So that's going to be a message with the subscribe command. And notice how we have some headers like the destination. And this handler will delegate to a controller annotated with add subscribe to a method inside a controller annotated with add subscribe mapping and defining the destination to be processed. So we see here that we are kind of intercepting the subscription. We can actually do some stuff and we can return something back to the client. So this return will be sent directly to the client. Of course, the subscription will be managed by the broker, but this return will be streamed directly or sent directly to the client. So that's subscription handling. So what about message handling? What happens when a client sends a message to one of these application destinations? So we see on the client side that we use this STOMP client to send a message to a destination, which is an application destination. So that will be a JSON string. So this JSON string will be the body of this STOMP message. So we have here this send STOMP message, which will be sent to the destination /app/chat message. And the body of the message is basically this string, this JSON string. So this will match a handler method inside our controllers annotated with a message mapping. And notice that the signature is quite flexible. So in my signature here, I'm defining this chat message, which is just a pojo, right, over my class, which is annotated with that payload. So there's going to be a conversion here between JSON and my object. We also specify that I want to get the principal. So this principal is basically the principal acquired in the handshake. So whenever we started the WebSocket session, we did this handshake. So this is the principal that we got in this process. And notice how we are getting the message, we are doing some processing, and we are returning something. So this something will actually be sent to the broker. So the broker will receive what's returned by our controllers. You have a question here?
That destination that you mentioned there, does that map to a real IP of some kind?
To a real IP?
Yeah, let's say my client is a browser, and so it's HTML5 based client, and I'm implementing WebSockets. So does that destination map to a IP address that can be found over?
So the question is here, is this destination mapping an IP address in my server? So actually, you have also already established a connection with the server side, right, using this handshake. So that's actually the connection that you have established, and you're sending messages over this connection. So it's not like you're matching a URL in your server. It's not like an HTTP request, right? So you're basically sending this message in the channel, actually in the TCP connection that you have established with the service. But that's not like a physical resource that you have in your web application. Right?
My connection is still my
Right, so just one connection. Okay. So in this connection, we're going to send this message, and notice how we are processing this message, and we are returning something else, right? An object. So this object will be sent to the broker. So notice that we are sticking to the POJO programming model. We don't know about STOMP, we don't know about messages, we don't know about anything. So the controller is not responsible to know about all this stuff. It's just a method having flexible signatures annotated with this message mapping annotations, quite similar with the REST support that we have in Spring MVC. So as said, we're going to use some message converters in order to convert the payload of the incoming request or incoming message to your arguments. So we have these three built-in message converters. We have the string message converter, the byte array message converter, and the Jackson message converter. So that means that you can define a POJO as an argument, and using Jackson, the payload of the message will be converted to your object. So basically that's what we have here. This JSON payload will be converted into a chat message, and these message converters will also be used in the return values from the controllers. So basically this chat message will be converted into JSON and sent to the broker. So what do we do with these return values? So as said, this simple annotation method message handler doesn't know about STOMP. It's delegating the messages to your controllers, but it doesn't know about the STOMP semantics. So that's why we need to forward this message to a broker, and that's really important to understand. It's really important to understand that we need a broker that can process these kind of messages, because if we get a subscription, what should we do with this subscription? If we get a message, what should we do with this message? Should we forward this message to all the connected users? So who's doing this job? So actually the broker is the responsible to do this job. So we have actually two options set, right? So we have the built-in broker and the full-blown message broker. Actually, we have a broker relay which delegates to a broker with a STOMP support. So we're going to see that all the messages processed by your controllers are going to be sent by default to a destination, right, which starts with /topic/ the destination that you chose as in your message. So we're kind of converting this message sent to /app/chat.message into another message sent to the broker channel with the prefix /topic, which is what we configured to be a broker destination. Right, and of course the return is wrapped into a message. So what if I want to override the response, or where to send the response to? We have this send to annotation, which basically lets you override the destination where to send the response to. So in that case, we are receiving a message to /app/chat message. We are processing this message, and the return will be sent to a destination called /topic/chat filtered. So by default, we would have this return sent to /topic/chat.message. And so that's a way to override directly the response. So what happens if we have any exceptions in our controllers? Because in Spring MVC, we have these exception resolvers. So here, we're going to introduce the add message exception handler annotation in order to process any single exception thrown within the controller. So whenever we have an exception, this method will be called, and you'll be able to handle this exception. And of course, we're going to return something to the client. So that will be basically a message, a STOMP message, and you can override this destination either with send to or send to user. We're going to see send to user later on, but this method will behave like a normal method inside our component, our controller. So Spring Integration or 4.1 has also support for WebSockets. So it adds the inbound and outbound adapter, and it also lets you forward the processing of a message to a Spring Integration flow. So here we have an example of that particularly. So we have an interface annotated with add controller, with a method annotated with add message mapping. So that means that this method will be responsible to process messages to /app/chat message. But this method is actually a gateway, defining a gateway to Spring Integration. So the argument here will be sent to another channel, which is basically the entry point to Spring Integration, called message channel. So we're going to see that we are going to forward the processing to a Spring Integration flow, and the response is going to be sent to the destination that we specify here. In that case, the response of all the Spring Integration processing will be sent to the queue.answer destination. So that's a really initial support, right? So I guess it's not final yet. Right, but we're going to have actually support for WebSockets also in Spring integration, so we can have a more complex processing, right, of the STOMP messages, right, relying on a Spring integration flow. All right, so let's see a little bit about these application destinations. Right? So we have here this client. Let's open a new browser. Let's add a new client again. Let's add John to the chat room. Here you go. So I can type in here. Let's see if we can see both. Yeah. So I can type in here, hey there, John. And I see that it's actually sent to the other browser. So every time that we type here in this input, we're going to send the message to an application destination. And this application destination will be responsible to filter this message because, of course, I don't want users to send bad words to my chat, right? So I have kind of a filter which filters the profanities, filters the bad words that user will send, right? So if someone comes here and then just tries to send that's a crap, we see that crap is not going to be sent, right? Because that's a bad word. I don't want users to send these kind of words. So basically that's going to be sent to an application destination. So let's see the application destination, which is, sorry, not profanity checker, chat controller. So that's basically a normal controller. And we see that we have this mapping here, the chat.message. So I'm going to send the message directly to this app chat message. Notice that the payload is converted into a chat message. And what I'm doing is I'm delegating to this method check profanity and sanitize. So we can actually filter the bad words from the message. So notice that this message, after being sanitized, is going to be sent directly to another destination. By default, that's going to be /topic/chat.message. So that's basically what we are doing, right, with these application destinations. We can kind of filter, we have a kind of proxy to process this message, but at the end of the day, we have to send that into the broker. So this return will be sent to the broker so it can be broadcast to all our connected users. And we actually see here another application destination, which is this chat.participants. So what happens when I log in or when I join the room? So actually I'm going to subscribe to this app chat participants, and this will be intercepted by my controller. So this controller will basically give me the collection of the registered users. So we have seen that whenever we enter the chat room, we saw all the connected users. And that happens at this point. I subscribe and I get all the messages because I'm going to subscribe to an application-specific destination. Okay, so as said, these guys, right, the return from the simple notation method message handler will be sent to the broker channel. So it's going to be sent to this STOMP broker. So this broker will receive messages from the broker channel, but also from the client and inbound channel. So depending on the prefix again. So again, we have these two options. We have the simple broker. The simple broker is really good if you want to get started with Spring WebSockets, if you want to use it in development and testing. But I mean, it's not, it's production ready, yeah, but it's really difficult to scale because we are storing everything in memory. We are storing subscriptions in memory. We are storing all the user sessions in memory. So it's going to be really, really difficult to scale with that approach, but you can use it. Right, so if you configure this simple broker, you're going to have this simple broker message handler as a subscriber into the inbound channel and also the broker channel. So we have seen how to configure that already. We have seen how to enable this simple broker. So everything will be delegated to this in-memory broker. But as said, if you want to build a real world application where you need to scale your application, you want to rely to, or actually forward everything to a full-blown STOMP broker. We have different brokers. We have RabbitMQ supporting STOMP. We have ActiveMQ supporting STOMP, HornetQ, OpenMQ. All of them support STOMP. And we see here the configuration. So now instead of enabling the simple broker, I'm going to enable this STOMP broker relay. And here you can define the prefixes, but also all the attributes to connect to your external broker. So in that case, you have a standalone broker, and basically Spring will delegate or forward all the messages to this STOMP broker. So that's what we're going to get. Right? So we're going to get this STOMP broker relay message handler instead of the simple broker. And it's going to process messages from the inbound channel and also from the broker channel. So in the broker channel, we basically get what's returned by the controllers. Right? So the controllers, as I said, are kind of a bridge, as we have seen in this message here. Right? So basically, that's a bridge. At the end of the day, we're delegating to the broker. Great. So a word on destinations. Right? So we have seen how to specify application destinations, how to specify broker destinations, but the STOMP protocol itself doesn't define anything or how these destinations need to be defined. Right? So actually, it's up to the broker how to implement, right, these destinations. Other protocols like MQTT define how these destinations need to be configured, or how to define these destinations. For instance, it defines that the segment is a slash, right? So in STOMP, we don't have any specification on how to define destinations. So it's up to you, the developer, right? Or the developers are basically building this kind of destinations, but you have to be aware on how the broker is actually processing these destinations. So going for a slash is really convenient for us as web developers. But in messaging, we tend to use the dot instead of the slash. So if you use the simple broker is actually not aware of STOMP either. But it will be happy with destinations with the slashes, destinations with dots, everything, right? But if you delegate to RabbitMQ, for instance, RabbitMQ is using the dot notation, right? Because, well, that's basically what's used in AMQP. So it's basically reusing the same semantics. So if you go for RabbitMQ, then you'll have to use the dot notation instead of the slash, a separator in your destinations. So as long as you can prefer the dot notation, actually if you use RabbitMQ, for instance, there's not going to be any other way to define these destinations. You have to go for the dot notation. Great. So we're going to delegate to this external broker, right? So that means that we're going to establish a TCP connection. And we're going to use Reactor, right, in this TCP connection. Sorry, we're going to see that later on. But basically, this TCP connection can go down, right? So maybe RabbitMQ goes down, maybe something happens in the connection. So what happens here? We're going to send heartbeats to the broker to see whether the broker is alive, because at the end of the day, we need to send or forward the message to the broker. But what happens when there's a failure here? When there's a failure here, we're going to get a notification, an event, which is called broker availability event. Right? So that will tell us that the broker is down or there's no connection to the broker. So we're going to get this notification saying that it's not available. So we're going to try to reconnect all the time. Right? So we are basically doing the auto reconnect transparently. So whenever the broker is up again, we're going to get another notification called broker availability event. So we're going to know when the broker is up again. But the reconnection is transparent to us. But what happens when the client disconnects? So there's a connection outage, or the app goes down. So actually there's no automatic reconnection happening, right? So Suck.js doesn't reconnect automatically. Other frameworks or other libraries like Socket.io will do that, but Suck.js doesn't have that implemented. So that means that the reconnection on the client side needs to be done by you, right? So whenever we get a disconnect, you'll have to reconnect again yourself. So basically, you're going to get a disconnect error, and you're going to intercept that error and implement the reconnection logic, which is quite simple, but you'll have to do it manually because on the client side, we won't have that support. All right, so let's see a little bit about the broker destinations. So the broker destinations are the ones that are sent directly to the broker. So they're not going through our controllers. We have seen that application destinations go through our controllers. We can process them, and at the end of the day, they will reach to the broker. So here in my sample, we have an example of a broker destination, which is basically when we are typing in the chat, we're going to broadcast this typing to all the connected users. So I'm going to come here, this second user, I'm going to start typing. So as long as I type, you see in the first browser that I'm typing, right? So that's basically sending this typing event directly to a broker destination. So every single user is subscribed to this topic, so it's going to receive that, that message without going through the controller. So everything is managed by the broker itself. So in my configuration, I have RabbitMQ. That means that the message will be sent to RabbitMQ, and RabbitMQ will handle this message, and it will broadcast this message to all the connected users. Do you like what you see? Yes? Yes. Clap, tweet. Yeah, great. Yeah. Any questions so far?
I have a question. Is RabbitMQ really doing the forwarding, or is it just acting as a registry there? Is the broker doing the forwarding?
Yeah, so the question is RabbitMQ doing the forwarding, or is just a registry for the sessions? So actually, RabbitMQ has its STOMP plugin, and is actually dealing with everything, subscriptions, messages, and everything. So we may have one incoming message, but RabbitMQ will send multiple messages to the connected users. So every single user which is connected will have its own connection to RabbitMQ, right? So that's how we correlate the users with RabbitMQ. So we're going to have a connection for every single user session. Right? So we're correlating the session ID with the connection this way. Right? So RabbitMQ is the responsible to do everything. Okay.
If you have a multiple server deployment, if you have a multiple server deployment, go into a single RabbitMQ or your RabbitMQ locally and somehow join them.
So the question is, if we have a multiple node application, how will this work, right, with RabbitMQ? So RabbitMQ is a standalone broker, so you can have multiple nodes connected with the same RabbitMQ instance, and that will work because every single node will have its own connection, or every single WebSocket session will have its own connection to the RabbitMQ, so that will work transparently, right? And also RabbitMQ can be clustered easily, right? So you can actually scale RabbitMQ as well. But you have multiple nodes of your application connected to the same RabbitMQ, that will work transparently as well, which doesn't happen with a simple broker. Of course, if you have multiple nodes of the same application, all of them will have an embedded broker, right? So that means that every single subscription will be stored locally in every single node, right? So that's why you have to delegate to a broker, right, if you want to scale.
So in your previous slides, you had a slide where the connectivity to the broker was cut down. So if that connectivity is lost, does the client have a local queue of some kind to at least take and store the incoming message so that when the broker is up?
So the question is, in this example here where the broker goes down, is the client going to have like a queue to receive the messages? So whenever the broker is down, we're going to receive this notification, right? And actually, we are sending heartbeats both on the client side and the service side. But actually, if the heartbeat is lost, that means that the client will be disconnected as well, because the heartbeat now is managed by RabbitMQ, right? So we're going to have kind of a heartbeat, right, from the client side directly to the broker. So if the broker goes down, there's no heartbeat, so the STOMP client will say, okay, there's no one on the other side, I'm disconnecting. Right? So that's the side effect of that, right? So that, I mean, if the broker door doesn't go up in like 10 seconds, then the client probably will be disconnected as well. All right. And the last type of destinations are the user destinations. So basically, every single destination starting with /user will be converted into a user-specific destination. So if you're subscribing to /user/q.chat.message, then we're going to create a specific destination for that user. So this will be converted into /q/chat_message user2244, for example. Right? So we're going to create unique destinations for this WebSocket session. So how can we send a message to a specific user? We have these kind of destinations starting with a /user. After that, we can specify your user, and you basically define the destination name, which will be /q/chat_message. And here's basically a convenient annotation to forward the response of a controller to a user directly. So by default, this send to user annotation will send the response to the same user session. So we're basically sending the response to the same user. But you can send the messages directly to other users which are not the ones in the same session. Right? So we're going to see that using the messaging template, you can send messages to any user in your application. So here's the destinations. In my chat app, I can send like global messages, but I can also send private messages. So we see here at the bottom that you'll send this message to everyone. But if I click on a participant, which is this one here, John, you'll send this message to John. Right? So I can actually type something, hey John, and we see that we send a private message from us to John, and on the other side, we got a private message from Sergi. So that's actually sending a message directly or specifically to a specific user, so without broadcasting this message. And what I'm doing here is mapping this destination called chat.private username. So notice how we can define placeholders in our destination. We can get these placeholders using the destination variable annotation, like what we have here. And we are basically sanitizing the message because we don't want any profanities in this message. And we're using this simple messaging template to send the message to a specific user. So this simple message template is basically a way to send messages to any destination, but it has some convenient methods to send to a specific user. So we have this convert and send to user. We define the username, which is basically what we pass in the destination. And we also define the name of the destination where we want to send this message to. So this will be sent specifically to a destination for that user. Right, so that would be one way to target specific users. All right, so that's basically what Rosen introduced last year. We need to understand a little bit about the processing of everything. But Spring 4.1 has some new features. So Spring 4.1 has a new WebSocket scope. So this WebSocket scope lets you define bins for a specific user session. And actually, you also have exposed all the header, all the attributes for the session directly using this header accessor. So basically, the first handler that we have seen, the simple annotation method message handler, will expose all the attributes from a session directly into the thread local, right? So into an object which is thread bound. So getting access to this thread bound object is possible using this header accessor. So notice that in this message mapping, we define an argument which is a message accessor, the header accessor, and we are getting access to the headers which will represent the headers in the current WebSocket session, because every single session, or actually WebSocket connection, will have its own WebSocket session. And this actually lets us define WebSocket scoped bins. So you can define a new scope. So I guess that you are familiar with the scopes in Spring, the singleton prototype, session request, thread as well, right? So now we have the WebSocket scope. So we can define a bean to be scoped at a session, WebSocket session. And actually the lifecycle callbacks will be also executed. That means that post-construct and predestroy will be executed post-construct whenever we do the dependency injection, after doing the dependency injection. And predestroy is basically executed when the WebSocket session is finished. So that's quite interesting. So in my application, I have a WebSocket scoped bean, which is the profanity level of a user. So every time that a user sends a bad word, I'm going to store it, right? So I'm going to check how many times you send bad words. And if you reach the max profanity level, which I set to 5, we are going to be banned from the chat, right? So I'm going to start writing bad words, sorry about that. Like, damn you see that? Well, that's not in that, John. I'm not sure if damn is one of the profanities. Let me check that for a second. That's in the chat config. So let me see. Yeah, so that's basically the filter. And basically we have this session profanity, which checks the profanities, right? So let's see if we define here. Grab, sorry about that. 1, 2, 3. I had some other profanities. So we reached the max profanity level that you are banned. And basically, this session profanity is tracking the number of messages that you are, or actually the bad words that you are sending. So if you reach the maximum level, we are going to be banned, right? So on the other side, we see that we can still write messages here. But on this side, we see that, hey, you reached the max profanity level, you cannot send anything else. And of course, if I actually refresh the browser, I'm going to be in another session. All right, sorry, well, let's start with that. So I'll be able to send messages again, right? Damn. Okay, great. So that was an example of a WebSocket scoped bean. New features, performance and monitoring. So we have seen a little bit about the client inbound channel, about the client outbound channel. So every single incoming message will go through the inbound channel. All the outbound messages will be through the outbound channel. So these guys are executor subscribable channels. We have seen that we have several subscriptions on these channels. But as the name says, we're going to have a thread pool executor doing the handoff of these channels. So we can have some thread pool executors configured to do the handoff of these messages. So we can have the client inbound channel executor and the client outbound channel executor, one for the inbound channel, one for the outbound channel. Both of them are configured by default to the available processors plus or multiplied by 2. But what happens if your controllers, for instance, are doing, I don't know, I/O operations, are interacting with a database, are doing some I/O operations which may block, right? You may want to increase the number of threads because, I mean, you won't be doing anything. You'll be blocking for the I/O operation. So you can actually modify or configure these thread pool executors in the configurations. We see here the same class, the WebSocket message configuration support, which just lets you define a task executor for the inbound channel inside the client inbound channel method, and another task executor for the outbound channel. So in our case, we are doubling, right, our default. So we are getting the max processors and multiplying them by 4. So that's basically something that you can modify in order to get more performance if your controllers, for instance, have a lot of I/O bound operations which are performed. All right, so whenever we get messages, we're actually in the inbound channel, it's kind of you can't predict how many messages are going to get, because you can more or less predict the load of these messages. But that's really hard on the outbound channel, because if you take, for example, the chat sample that I've showed you, every time that someone sends a message, it needs to be broadcast to all the participants. So that means that if we have a new participant, there's going to be a new outbound message. So we're going to kind of multiply the outbound message. Right? So one incoming message will be like 100 outgoing messages, right, for 100 participants. So if you are not like fast enough to hand off these messages to the clients, or maybe if the clients have a really slow connection or cannot receive like in the same pace, then you'll be buffering all these messages. So you can configure how this buffering works, or how long you want to store these messages in memory. Right? So with these two properties, the set time limit and set buffer size limit, you'll be defining all the buffers or all the messages that you want to buffer. So this send time limit defines the maximum amount of time of sending, or allowed for sending a message to the client. So by default it's 10 seconds. And the buffer size limit is defining the amount of data that we can buffer, right, in the outbound channel. Right? So if you want to disable buffering, you can just use 0, right, as a parameter, and you'll be disable buffering at all. So here's how the configuration inside the same WebSocket configuration. You can override this method, configure WebSocket transfer. And notice that it lets you define the set time limit and the set buffer size limit. So you actually tweak a little bit how you want to buffer the outgoing messages. So in order to tweak these kind of things, in order to increment the thread pool, in order to increment the buffer size, you have to do that accordingly to something. So that means that you need to monitor, right, the performance, or how your application is performing. So Spring 4.1 is introducing this WebSocket message broker stats. So this guy will tell you about a lot of details on your application. So it will tell you about the thread pools. It will tell you about the incoming thread pool, or the inbound thread pool. It will tell you about the outbound thread pool executor. It will tell you about the messages that have been processed, how many connections we have currently. So it's giving you all the stats so you can monitor your application in real time. So by default, this guy will log, right, all the stats every 30 minutes. But you can take this guy, expose it into HTTP, expose it into JMX, so you can have these live stats directly into your application. So here, I'm going to log out in my chat application, and I have to Sergi. Have to be an admin to see the stats. So I'm going to add the password rock and roll, and I'll be able to see the stats. So see here the stats that I have 2 current connections. I have processed 7 connect messages, 7 connected messages, no disconnections. Well, I see everything here, right? So how the thread pool for the inbound channel is behaving, and all this stuff. So you should take a look at all these stats in order to tweak the configuration on your WebSocket application. Because if you see that the buffer is filling, that means that you may, do something wrong. So usually there shouldn't be buffering. You should process the message as they come in and go out, right? So if you actually have some kind of buffering here, maybe you want to tweak a little bit your configuration as well. So last thing that Spring 4.1 is introducing is the Java client. So we have seen how to use the JavaScript client, but JavaScript is not the only way to communicate with our application. And this SockJS Java client is quite interesting if you want to do server-to-server communication. We have seen how to build our WebSocket support for the server side, but on the client side, you may not use a browser. You may actually use an application, and that's the way to go, right? So to use this SockJS Java client. It doesn't have support for STOMP. That means that it only has support for SockJS. You'll be able to communicate with the server side, but the STOMP client is not done yet, I would say, because I would say that the STOMP support will be there at some moment. But for now, you'll be able to just define the SockJS Java client with the different transports, WebSocket, polling, and streaming, and be able to interact with your server side. So you have all the fallback options as the ones that you had in the web environment. So some of them doesn't make sense if you're not in a web environment, but at least if you have a firewall in between the two servers, you'll be able to use the application because you're going to have this one of these fallback options. And this SockJS Java client is also really useful if you want to simulate high load to your application. Right? So you can actually start as many connections as you want to your server side, and that would be the way to define load testing, right? So for your WebSocket application. All right, any questions so far? I can hear you. So the question is, imagine that WebSocket is not available. Is there any fallback? Right. So in the browser, we have seen that we have fallbacks. So for instance, if you use a browser which doesn't support WebSockets, we're going to fall back to streaming or polling like the old days. Right. But in here, we also have the same fallback options as said. Right. So if you cannot use WebSockets because of your environment, because you have a firewall, then you can have the fallback options as well. Right? So it's kind of behaving, right, the same behavior as we have in the web layer, where you have the fallbacks all the way. Okay, WebSocket security. So we know that we're using HTTP for the handshake. So that would be the first place where you want to apply security. Right? So we know how to use Spring Security to protect HTTP requests. So you may want to protect this handshake. So not everyone can start a WebSocket connection. But what happens when we have this WebSocket connection established? We don't have any security defined in the GSR or anywhere else. So Spring Security 4 is going to introduce the WebSocket security. It's not final yet, just the first support. Right? So what you're going to see here may change. But the Spring Security 4 will add some interceptors to both the inbound channel and the outbound channel. So basically, these interceptors will do the security at the message level. Because we're not in HTTP, we are not protecting URLs, we have to protect messages. So the way that we configure that is by extending this class, the abstract security WebSocket message broker configurer. And you're going to configure how messages will be protected, or actually how destinations will be protected. You can also use the Spring Security annotations like the pre-authorized and the post-authorized that we use for method security. You can use them here as well. Right? So these are the two options to define security. So the flow will go something like this. We're going to get a new STOMP message, right? A new message, a new frame, right, in our application. We know that everything is sent to this client inbound channel. So this client inbound channel will have some interceptors configured by Spring Security. So the first interceptor is this security context channel interceptor, which will expose the security context in a thread-bound object. So basically, it's setting this security context so we can access it for, well, within the message processing flow. So the second interceptor that's going to configure is the channel security interceptor, which is the one responsible of securing the right message. So it's delegating to the access decision manager. And this access decision manager will be configured by with a voter called the message expression voter. So it will check, right, that we have rights to send messages, subscribe to destinations. And in that case, we're going to delegate to our message handlers. So security for WebSockets happen, right, at the inbound channel and the outbound channel as well. So applying security to the outbound channel may not be the most effective thing, because we know that for one incoming message, we may have like hundreds of outgoing messages. So filtering all the outgoing messages may take a lot of time. So that will also affect your performance, right? So maybe you want to avoid applying security on the outbound channel, just the inbound channel, but actually you can configure that as you want. So here's the configuration where you define these destination matchers to specific destinations, and you define how you want to protect these destinations. So notice that we are protecting these destinations with specific roles, and that will protect both subscriptions and messages. So that means that you can only subscribe to /topic/admin whatever if you have the admin role, and you'll only be able to send messages to this destination if you have the same role. But in the future releases of Spring Security, you'll also have a way to configure security for subscriptions and for messages, because maybe you're allowed to subscribe to a destination, but you're not allowed to send messages to those destinations, right? So that's something that you may want to configure. So in the next versions of Spring Security, that will be there. So the other way to protect subscriptions and messages is basically using the traditional Spring Security annotations like the pre-authorize, and we can actually protect the subscribe mapping annotation messages and the message mapping methods. So protecting subscriptions and messages as well. And that's really important. I mean, configuring security is really important because we don't have anything there. I'm going to just do a really quick demo, because we have seen this profanity filter. So if I just type here crap, whatever, right, the crap is filtered, but you can actually go through the application. I mean, go directly through the broker by modifying the source code, for instance. So let's use the developer tools to kind of hack this application. So developer tools is a really good tool to debug applications. Actually, you're going to see the console as the STOMP client has debug enabled, so you're going to see all the messages going in and out. And actually, the network tab is also really useful, right, for these kind of things, because you're going to see all the frames coming in and coming out. So what I'm going to do is basically modify where I'm sending the message when I type in the chat. So I'm going to say that instead of sending the message to /app, I'm not sure if you see it from the back, but that's the destination where I send messages to. So I say instead of sending it to app chat message, I'm going to send it to topic chat message. So I'm kind of cross-circuiting the workflow. So instead of going through the controller and reaching the broker, I'm going directly to the broker. And I'm going to modify here also some parameters, say username, Jürgen. Okay, great. So now, when I'm sending a message, it's like crap, ha ha ha. Right? Oops, that's not what I wanted. So maybe I did something wrong. Let's refresh that. Just a second. Do that again. Change that topic. Sorry, it's this one here. Topic. Modify that. Username. Jürgen. Let's see if that works. Demo effect is always there. Oh, here you go. All right. That's not working now. So demo effect, I'm going to show you later on, right, in private. Right, but actually, you could modify how the message is processed if you don't have security here, right? So you want to have security in every single destination, and that's what WebSocket security is going to add. So far, we don't have a way, or actually a straightforward way, to define security for messages and subscriptions independently, but at least you can protect destinations itself, right? So that's something that you may want to look at in the new releases of a Spring Security. Okay, Spring Session, right? It's another project which is quite handy. What's the challenge when we implement WebSocket applications? We're going to start with an HTTP request, that's fine. So you may be in an application which uses the HTTP session and also WebSockets. Like, imagine like a Gmail style application where you have AJAX requests to send messages, to send emails, and also you have a chat which may be implemented with WebSockets. What happens when you start this session, the HTTP session, and you're there in the chat like for an hour? So you're going to establish the HTTP session, you're going to establish the WebSocket session, you'll be sending WebSocket frames right, up and down, but eventually the HTTP session will expire because it may be like configured to be 30 minutes, so it will expire. So whenever we have the HTTP session expired, the WebSocket session will be closed as well. So that means that if you want to implement a WebSocket application, you have to ping the server side all the time to maintain the HTTP session alive. Right? Otherwise, you're going to have the WebSocket session closed for you, and that's not what you want because you are interacting with the application. You're sending messages to the WebSocket protocol. But the HTTP session will expire, so everything will be closed. So in order to synchronize the WebSocket session with the HTTP session, we can use a Spring session. So Spring session is doing a lot more. So it's actually providing a common infrastructure to manage sessions. So a session doesn't have to be bound to HTTP, right? So actually that's why Spring session lets you interact with the session everywhere in a web, in any component. So a session would be like a kind of a storage for that specific session, but it's not web bound. It actually lets you cluster the session in a vendor-neutral way, so you can implement sessions in Redis and you don't have to configure this session clustering in your application server. So it's basically working in every single container. You can define how the session is done, but the most important thing for our topic is that it keeps the synchronization of, or synchronize the HTTP session with the WebSocket session. So that means that we don't have to ping the session, the server anymore. That's going to be done with Spring session, right? So we're going to have the WebSocket session alive even if, well, the HTTP session was supposed to expire. So this HTTP session won't expire, so we're going to be happy, right, with a WebSocket session. So said this is not final, it's in milestone 1, right? But that's something that you also want to look for if you implement WebSocket sessions. And the last thing that we're going to cover slightly is the testing WebSocket sessions. So what do we need to test? We need to test several stuff. We need to test our controllers first. We have seen that our controllers are just poachers, like similar to the ones from Spring MVC. So it's going to be really easy to unit test these controllers. But unit testing these controllers is not going to be enough because we are not involving the infrastructure. We're not involving the channels. We're not involving the resolution of the variables in the message handler methods. So that's why we have to go for another level of testing, which is the out-of-container integration testing. So there are two ways to this kind of integration testing, integrating basically the components that we have seen. The first thing that you can do is to bootstrap the application context with the test context framework in a JUnit environment and basically get a reference or inject the client inbound channel and send messages directly to the client inbound channel. So you're going to go through all the flow by sending messages, which are like normal messages, to this channel. The second way to do that is by setting up the infrastructure yourself. So you can create a new simple notation message handler, define the different controllers that you have, and basically send or pass messages to this handler. So that would be another way if you don't want to bootstrap the whole application context in a test environment. And the third type of testing that you may want to look for is the end-to-end testing. This is not like an end-to-end testing involving also the JavaScript client side, but still you can have an end-to-end testing, and for that you'll need to have a kind of embedded WebSocket server. So using the SockJS Java client that we have seen, you can actually implement this kind of tests. So you can embed a WebSocket server and use the Java client to start WebSocket connections and send anything to those WebSocket connections. And that's basically what you have to do if you want to implement low or high volume testing, right, for your applications as well. So that's the way to go, by using the SockJS Java client and basically implement testing, sending like a bunch of requests, right, to your server side using this client. So that doesn't involve the JavaScript part, because of course if you're doing a web application you may be using the SockJS JavaScript client, right? So that's not involving this layer, but at least you can have kind of end-to-end testing using the Java client. All right, so that's the end of my presentation. We have seen a little bit about the workflow. We have seen a little bit about the new features and a little bit about the other projects having support for WebSockets like Spring Session and Spring Security. Questions here?
You mentioned back on Spring Session that it will keep the HTTP session and the WebSocket session in sync. That assumes that it's going to be on the same node. So does it somehow, are you guaranteed that both connections will end up to the same node, same server?
Actually, yes. The question is, do you guarantee that the HTTP session and the WebSocket session will be in the same node? Actually, you're starting with an HTTP HTTP request, so you should be in the same node, actually, by providing any of the sticky sessions, or it's up to you how you define that. But you should.
Session for HTTP, I'm just curious, so somehow the WebSocket.
So actually, you're starting with the HTTP request anyway, right? So you're going to, depends on you, right, how you configure that, but you should actually end up with the same node. Another question here?
So if you look at the form factor site, they say that if you're looking at a cloud-based application, you should not expect sticky sessions.
Mm-hmm.
So, but is sticky sessions a requirement to get Spring Session working?
Actually, no. Right. So the question is sticky sessions a requirement for a Spring Session? That's not a requirement for that. It's up to you how you configure that. Yeah.
Okay, so
I'm just going to, isn't it the case that the session is held in Redis, so even if
Yeah, it's in Redis actually.
here and WebSockets over there, there's a single session, it's a shared session.
So that's why. Yeah. So Redis is the implementation, right, or actually has support for Redis Spring Session. Redis can be clustered quite easy, right? So, any other question here?
What are the resource implications of using WebSockets?
So again, the resource?
Resource implications as far as, network connectivity. I mean, it sounds like there's a lot of heartbeat going back and forth, like you mentioned, but HTTP doesn't necessarily have that. So is that a lot more over HTTP? Or?
So the question is, what's the resource implication when using WebSockets? So of course, you're going to have a long-living connection to the server side, right? So in HTTP, you have a connection, and it's basically living this request. So with WebSockets, you can have a long-living connection to the server side. So that means that scaling WebSockets may be a little bit harder, because at the end of the day, you can have a constant connection all the time. And well, you say there's going to be a heartbeat because we need to maintain this connection alive. And but the frames for WebSocket are really, really small compared to the HTTP headers. Because if you want to implement any real-time application with HTTP, you'll be using like long polling or streaming, right? And actually, at the end of the day, we'll be sending the HTTP headers, right, all the time, every time that you receive some kind of data, anyway. So the heartbeats are really, really small, right? The frames are a couple of bytes, right? Sending them from the client side to the server side and the other way around, right? But you can configure also when you want to have heartbeats as well. So how frequent you want to have these heartbeats. It's up to you. For instance, you're dealing with mobile applications. You don't want to have this heartbeat all the time, right, up and down, right? Because that's consuming data. Connectivity and so on. So you may want to have a longer period for these heartbeats.
Is there a maximum number of how many WebSockets you can actually have open?
Actually, it's quite high. There's a number, but it's really, really high, I think.
Like in the thousands or?
Yeah, I think it's hundreds.
So how does RabbitMQ help with that scaling?
Mm-hmm.
You said you could have multiple brokers, you have high availability, load balancing, and that sort of thing.
Mm-hmm. So the broker is responsible to process these messages, right, the STOMP messages, because it understands the STOMP semantics. So if you go for the simple broker, that means that all subscriptions are going to be stored locally in memory, right? And everything is going to be in memory. So if you have 2 nodes, you're going to have like several subscriptions and a separate like things for different users. So it's not scalable. I mean, you don't have a cluster for that. But RabbitMQ is basically another standalone broker. So every single node will connect to that broker. Right? So it's not bound to the application node. It's basically a standalone service, right? Which can be scaled at the same time, but you can have multiple application nodes connecting to the same Rabbit node. So everything was managed in there. So every single WebSocket session will have a connection to RabbitMQ, right? So every time that we get an incoming message that we have to broadcast, RabbitMQ will create these messages to all the connections that are subscribed to that specific destination. Right?
Yeah, the quick search revealed a few different implementations of the client-side JavaScript STOMP client. Which one were you using?
Mm-hmm. It's called STOMP.js. Right? So there are actually several, but the official one is STOMP.js. Okay. The question was, what client implementation are we using here? This is on GitHub. Actually, Rustin has another example. You can just take a look at the GitHub and see the dependencies as well. So they are managed by Bower, right? So there's a file for Bower with all the dependencies, so you can see all of the dependencies there.
You mentioned RabbitMQ a couple times. Is ActiveMQ, there's an integration with ActiveMQ as well?
Well, it has a STOMP support, right? So, I mean, the broker relay is not aware of what you're using. Actually, it lets you establish the connection or define the password and how you connect with the broker, but it's not aware of what you're using after that. It's up to you. I mean, you can plug in RabbitMQ, ActiveMQ, whatever you want. Any other question?
What about if you're using an application server you're deploying, you have to have some level of support for WebSockets, right? Because it's negotiating things via HTTP WebSocket requests. Are there any things to look for with some of the popular application server vendors? I know JBoss, for example, just came out with support for it. Are there certain version levels or things like that to look for to be compatible with what Spring is providing here?
The question is, if you use an application server, should we know about versions and whether they support the WebSockets or not? Well, I mean, there's support for Tomcat, for Jetty, Wildfly, and another one, I think, right? So you have to take or actually know about the support that you have there. But you have also the fallback option, so maybe that's not what you want. But of course, that relies on the GSR. As well, so it's much better if you actually use when any of these application servers or servlet containers. Right? Otherwise, you're going to get kind of exception at runtime, having you don't have the upgrade strategy, right, to upgrade to WebSockets.
Yeah, I saw in the documentation and JBoss is only supported at version 8, but I work with version 7. What about use WebSocket implementation in JBoss 7?
Yeah, the question is, what about JBoss 7, right, for WebSockets? I'm not familiar with JBoss, fortunately, so maybe we can talk with Rustin if he has some experience with JBoss 7 and WebSockets.
It doesn't support WebSockets.
Yeah.
But it supports server async, so Wildfly 8 supports WebSockets.
So the thing is that, well, if you use SockJS, you have this fallback options, right? So that's what I'm saying. If you cannot use WebSockets, then you're going to use any of the traditional approaches like polling or streaming, basically. last question, I guess. Actually, no. Right, so we have, the question is, can we use Socket.io instead of Sock.js? There's no support right now. Right? Actually, the new version of Socket.io came out recently. It was kind of a dead project, but all of a sudden it came out with a version. But we have actually the Sock.js support on the server side, because you need to have the server-side support and the client-side support, right? So we don't have support for Socket.io, and Socket.io works differently, right, with these amids and all this stuff. So it kind of changes the things that we're using in Sock.js anyway. It has the role of rooms as well, and different stuff which is not in Sock.js. So we don't have support for Socket.io right now. Yeah. I can hear anything with all the incoming people. I'm not sure whether we are running out of time.
2:30 is the next one, so you got to kind of.
Okay, so maybe we can leave it here, and we're going to leave the questions for the break. Okay, thank you very much.